Welcome to this presentation on ionic and covalent bonds. In this lesson, we will explore how atoms bond together to form compounds and how these bonds explain their properties. By the end, you will be confident in explaining ionic and covalent bonding, drawing dot and cross diagrams, and linking bonding to physical properties. Chemical bonds are the forces that hold atoms together to form compounds. The two most important types you need for GCSE are ionic bonds and covalent bonds. A common exam question asks you to compare the two types of bonding, so pay close attention to the differences. Atoms bond to become stable. They do this by achieving a full outer shell of electrons, similar to the noble gases. In answering exam questions, always mention stability and noble gas configuration when explaining why bonding occurs. An ionic bond is the strong electrostatic attraction between oppositely charged ions. This force holds the ions tightly together in a regular structure. Ionic bonds happen when a metal reacts with a non-metal. Metals lose electrons, while non-metals gain electrons. Note: whenever you are asked to define an ionic bond in exam, always use the phrase strong electrostatic attraction in your answers. Let's look at sodium and chlorine. Sodium has 1 electron in its outer shell. Chlorine has 7 electrons in its outer shell. Both atoms are unstable because their outer shells are not full. Sodium transfers its 1 outer electron. By losing this electron, sodium becomes stable with a full outer shell underneath. It is now a positively charged sodium ion. The electron lost by sodium is gained by chlorine. Chlorine now has 8 electrons in its outer shell, making it stable. By gaining this electron, chlorine becomes a negatively charged chloride ion. In exams, always show both ions with their charges, and don't forget to include brackets when drawing ionic diagrams. Ionic compounds don't just form pairs. They arrange themselves into giant ionic lattices. Each positive ion is surrounded by negative ions, and each negative ion is surrounded by positive ions. This creates strong electrostatic forces in all directions. These giant lattices give ionic compounds high melting and boiling points. They need a lot of energy to break the bonds. Ionic compounds conduct electricity when melted or dissolved because the ions are free to move. They are usually soluble in water. When answering exam questions on the high melting and boiling point of ionic compounds, always link back to the strong electrostatic forces holding the lattice together. Now let's move to covalent bonding. Covalent bonds happen between non-metals. Instead of transferring electrons, the atoms share electrons to achieve stability. Let's see some examples of covalent compound and how to draw their structure. Take chlorine molecule as an example. Each chlorine atom has 7 electrons in its outer shell. To be stable, chlorine needs just 1 more electron. When 2 chlorine atoms come together, each shares 1 electron. This gives both atoms a full outer shell. The shared pair in the middle is the covalent bond. In exams, always show the shared pair in the middle and the rest of the electrons around the atom. The overlapping part shows the pair of shared electrons. Around each chlorine, the other 6 electrons remain. This is how we draw the covalent bond of chlorine. Another example is the water molecule, H2O, which contains hydrogen and oxygen. Oxygen has 6 electrons in its outer shell. Therefore, oxygen needs 2 more electrons to be stable. Next, we add the electrons for hydrogen. Each hydrogen has 1 electron. Each hydrogen needs 1 more electron to be full. When oxygen joins with two hydrogens, each hydrogen shares one electron with oxygen. Now oxygen has 8 electrons in its outer shell. Each hydrogen has 2 electrons in its shell. This is the covalent bond in water. Exam tip: always count the electrons carefully before drawing. The number of electrons an atom share is determined by the number of electrons it needs. Oxygen needs 2 more electrons, so it must share with 2 electrons. That's why it give 1 electron each to the 2 hydrogen. This is how you decide how many electrons an element needs to share. Covalent bonds form 2 types of structures. Number 1. Small simple covalent molecules, like water and ammonia. And 2. Giant covalent structures, like diamond, graphite, and silicon dioxide. To watch the lesson on giant covalent structure, kindly click on the link at the top right corner above. As part of your exam, you are expected to know the properties of covalent compounds. Simple covalent molecules have low melting and boiling points. This is because their intermolecular forces are weak. Giant covalent structures, like diamond, have very high melting points. Graphite, although covalent, can conduct electricity because it has free electrons. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with Acestudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.